We're going to graph this rational function. How do we find the domain? Exactly. If I were to set the denominator equal to 0, what x value would give you 0? -2. So we cannot be -2. We do not want the denominator to be 0. So that means your vertical asymptote is at -2. To find the vertical asymptote, you set the denominator equal to 0 and you solve it. The horizontal asymptote is going to be y equals 1. Since the degree is the same, you're going to look at the coefficients, which is 1 over 1. So we just put 1. The zeros, how do we find zeros?
The numerator.
Exactly. Set the numerator equal to 0 and solve. So what will you get? 4, or you can write it as a point, 4, 0. Okay, the y-intercept. To find the y-intercept, what do you do? Yes, plug in zeros for all of your x's, so you'll be left with -4 over 2, which is just -2. So your y-intercept is 0, -2. Now let's talk about the interval work. For the interval work, you only need to pay attention to the vertical asymptote, which is at -2, and the 0, which is at 4. You only pay attention to these two items, the vertical asymptote and the zeros. So we're going to plug in numbers that are less than -2. So can you guys give me a simple number that's less than -2? That's good. Let's do -3. So if I plug in -3, I'll get a negative on the top and a negative on the bottom. So this is positive. If I plug in a number between -2 and 4, such as 0, let's see what happens. What do I get if I plug in a 0? I get a negative. Okay, now let's test a number greater than 4, such as 5. If I plug in 5s, I get a positive in the numerator and a positive in the denominator. That means this interval would be positive. So let's go ahead and graph the key features. I have a vertical asymptote at -2 and a horizontal asymptote at y equals 1. I also have a 0 at 4, and the y-intercept is at -2. Okay, so let's go ahead and graph my rational function. We're going to use our intervals. So I know when I am less than -2, I need to be positive. So this is less than -2. I need to be positive. So my graph will be up here. Between -2 and +4, I'm going to be negative. So between -2 and 4, I'm going to be negative. But after 4, I become positive. That's why I go up here towards the asymptote. So you guys try this one. Okay, so your domain. We do not want 0 in the denominator. So you do not want 3 as a part of your domain. Because if you plug in a 3 here, this will be 0, and we don't want that. That means we have an asymptote at 3, a vertical asymptote at 3. Horizontal asymptote. Our degree in the denominator is larger than the degree in the numerator. So that means your horizontal asymptote is y equals 0. Your zeros, you set the numerator equal to 0, but that is not a true statement. So you have no zeros. Your y-intercept, you plug in a 0 and see what's left over. We're left with 4/3. Okay, so let's do our interval work. You only look at the vertical asymptote and your zeros. So in this case, you're only looking at 3. So if I plug in a number below 3, such as 0, I get a positive. And if I plug in numbers bigger than 3, such as 4, I get a negative in the numerator and a positive in the denominator, so this is negative. So I'm gonna go ahead and graph my key features. Your vertical asymptote is at x equals 3. Your horizontal asymptote is at 0. Your y-intercept is at 4/3 or 1.33, so about right there. Okay, so when I am to the left of 3, I need to be positive. And when I'm to the right of 3, I need to be down here on the negative side. So in order to find the domain, just to make it easier, I'm going to factor the denominator to be x plus 2 and x plus 2. So that means a negative 2 would give me a 0 in the denominator. That means my vertical asymptote is at negative 2. Now, my degree in the denominator is larger than the degree in the numerator. That means your horizontal asymptote is y equals 0. For zeros, you set the numerator equal to 0 and you solve. So I'll move the 2 to the other side. I have negative x equals negative 2. Divide by negative 1, you get x is 2. So that is where your 0 is. Your y-intercept, just plug in zeros everywhere. And what would you get? Yep, 1/2. Because this would be gone, that would be gone, that would be gone. You're left with 2/4, which is 1/2. Okay, so now let's talk about the interval work. All right, so if I plug in, so my interval, we're looking at the vertical asymptote, which is at negative 2, and your zeros. You only have 1 0 at 2. So let's look at numbers below negative 2, such as negative 3. If I plug in a negative 3 here, this will become positive. And if I plug in a negative 3 here and here, these would both be negative, but a negative and a negative is a positive. So I get a positive. Okay, let's plug in a number between negative 2 and 2. So let's plug in a 0. If I plug in a 0, let's see what would happen. It looks like I get all positives. Okay, let's plug in a number greater than 2. So like 3, let's plug in a 3, I'd get a negative on the top. Plug in a 3 and a 3, I'd get a positive in the denominator. So a negative over a positive is a negative. So I'm going to go ahead and graph my important features. My vertical asymptote is at x equals negative 2. My horizontal asymptote is at y equals 0. I have a 0 at 2. And you're probably wondering why I put a point on an asymptote. You can cross a horizontal asymptote, but you cannot cross a vertical asymptote. Yeah. Okay, you cannot cross a vertical asymptote, but you can cross a horizontal asymptote. So that's where my 0 is. I'm not always going to cross it. I'll show you what this looks like. Then my y-intercept is at 0.5, so right there. So I need to be positive on the left side of negative 2, so I'm going to be up here. My graph needs to be positive. I have to be positive from negative 2 to 2, so I'm going to be up here, go through my y-intercept. But I'm going to be negative after 2, so I'll be down here. And that's what your graph will look like. We're going to factor the denominator so that it's easier to tell what my domain and my vertical asymptote is. So I cannot have -4 or a +4 in my denominator, or else it'll give me 0. So my vertical asymptotes are at -4 and 4. My horizontal asymptote is at 0 because the degree in the denominator is larger than the degree in the numerator. So it'll be y equals 0. Zeros, you set the numerator equal to 0 and solve it. That's just x equals 0. My y-intercept, you plug in zeros everywhere. So 0 divided by negative 16 is just 0. So my y-intercept is at 0. For interval work, you only look at the vertical asymptote and the zeros. So I'm going to look at -4, 0, and 4 and test numbers to see what I would get. So if I plug in a number that is less than -4, such as -5, I will get a negative in the numerator, a negative, and a negative in the denominator. Two negatives make a positive. A negative over a positive is negative. Now let's test a number between -4 and 0. I'll choose -1. So if I plug in a -1, let's see what I get. Okay, so if I plug in a -1, I'll get a negative in the numerator. I'll get a negative and a positive in the denominator. A negative times a positive is a negative. A negative divided by a negative is positive. Now let's test a number between 0 and 4. I'll test a positive one this time. So we'll plug in a +1. If I plug in a +1, I get a positive in the numerator, a negative, and a positive. Opposite signs, that's a negative. Opposite signs, this is a negative. Now I'm going to test numbers greater than 4. So I'll plug in 5. If I plug in a 5 here, here, and here, there's a positive in the numerator. This is positive and this is positive. Everything's positive, this is positive. So I'm going to go ahead and graph my key features. I have vertical asymptotes at -4 and +4. I have a horizontal asymptote at 0. And remember, you're allowed to cross a horizontal asymptote. I have a 0 at 0, and that's also where my y-intercept is. Okay, so when I'm less than 4, I have to be negative. So I have to be down here. Between -4 and 0, I have to be positive. So I need to be up here. But between 0 and 4, I'm negative. So I'm going to go down here. After 4, I'm positive. So that's up here on the positive side. Okay, so I'm going to factor the denominator to get x -2 and x +2. That means x cannot be -2 or +2, and that is also where my vertical asymptotes are. Since my degrees are the same, it'll just be the coefficient, which is 1/1, which simplifies to 1. The zeros, I'm going to factor the numerator so I can easily tell what my zeros will be. If I set this equal to 0 and solve, I'll know that my zeros are at -4 and +4. My y-intercept is 4. You plug in zeros everywhere, you're left with -16 divided by -4, which is 4. For the interval work, you're looking at the vertical asymptote and the zeros. So you have -4, -2, +2, and +4. Now we're going to test numbers. Remember, guys, whenever you square something, it becomes positive. So if I plug in a -5, this becomes 25. So 25 minus 16 and 25 minus 4 are both positive numbers. Now let's plug in something between -4 and -2. I'll plug in -3. So if I plug in a -3, this will become 9 minus 16 over 9 minus 4. This is a negative over a positive. So that's negative. If I plug in a 0, I'll get a positive. If I plug in 3, I'll get negative. And if I plug in a 4, let's see what I get. or something bigger than 4, I will get a positive. So I'm going to graph my key features. I have a vertical asymptote at -2, positive asymptote at x equals, another asymptote at x equals 2, horizontal asymptote at 1. I have zeros at -4 and 4, and a y-intercept at 4. Okay, so when I am less than 4, I have to be positive. When I'm less than -4, I have to be positive. Wait 1 second. Okay, so I'm positive before I get to -4. And then between -4 and -2, I have to be negative. So there we go. Now between -2 and +2, I have to be positive. So I'm going to be up here. Between 2 and 4, I have to be negative. So I'm going to start down here. So I'm on the negative side. And then after 4, I can be positive. So I'll go ahead and cross the x-axis and become positive. Okay. So I'm going to go ahead and factor this. Uh-oh. This will be x times x plus 3. This will be x plus 3 times x plus 2. Do you guys see what will cancel out? So this is what I'm going to use to evaluate what my graph will look like. So my domain, x cannot be -2 because then you would have 0 in the denominator. That means this is where your vertical asymptote is. Your horizontal asymptote, the degrees are the same in both the numerator and the denominator, so it's y equals 1. To find your zeros, you set the numerator equal to 0, so you have 0, 0. Your y-intercept will be 0. You just plug in zeros. Okay, let's talk about your interval. So we're going to have -2 and 0. You always look at your vertical asymptote and your 0 for this. So if you plug in a number less than -2, such as -3, you'll get a negative in the numerator, a negative in the denominator. That's positive. If we plug in -1, you'll have a negative in the top and a positive on the bottom. That would be negative. And then if you plug in a number bigger than 0, you'll be positive. So let's graph my key features. You have an asymptote at x equals -2, horizontal asymptote at y equals 1. You have to be positive when you're on the left side of -2, so you'll be here. You need to be negative between -2 and 0, after which you can become positive. Let me draw that better. Okay, now one thing I need to point out, we're going to talk about a whole. So a whole is whatever was common factors that canceled out in both the numerator and the denominator. You have a whole here. So there is a whole at x equals -3. So at -3, you're going to have a whole right there. So whatever cancels out, that is where your whole is. So you can create another section in your table. Your whole is at x equals -3. So whatever canceled out, just set it equal to 0. X plus 3 canceled out, set it equal to 0, and solve it. That is the location of your hole. So if I were to graph this correctly with my hole, it would look like this. And there's a hole in my graph. Okay, so this is letter F. If you factor this, you'll get x minus 2i and x plus 2i. Meaning if you set this equal to 0 and solve it, you'll get an imaginary number. If you get an imaginary number, don't worry about it. Okay, so it's going to be all real numbers. We're not doing imaginary stuff. If you set the numerator equal to 0 and solve it, it'll be the square root of 2 plus or minus. So you'll have x, oh, those are my zeros, x equals plus or minus the square root of 2. Your vertical asymptote, guys, your vertical asymptote, if you set the denominator equal to 0, you got imaginary numbers. We're not doing imaginary numbers. So you do not have, a vertical asymptote. Horizontal asymptote, what should it be, class? 1. These are the same, so you just do the coefficients. Okay, so guys, if you get imaginary numbers, we're not doing imaginary numbers. So just put none for the vertical asymptote, and your domain will just be all real numbers. So let me graph this for you. Square root of 2 is about 1 point something, so it'll be here. Your horizontal asymptote is right here. And your y-intercept will be -1/2. And if you do your interval, you're going to look something like this. That's what it will look like. You're only going to be evaluating at negative square root of 2 and positive square root of 2. So this will be positive, negative, positive. So that is what your graph would look like.